So this time, in addition to having all of you here at SF Ruby, sponsored by GitHub today, so thanks to them, and also brought to you by Evil Martians, of course. We also have a live stream, also thanks to the AV team at GitHub. And that's super nice because a bunch of folks I know were interested in joining the live stream, and we'll just send them virtual hi right now. I know we're live, and yeah, maybe I should give you all a link to that live stream. It's on my Twitter, but yeah, maybe a bit later. So we have a packed schedule today. We'll begin with Joel talking about GitHub's UI architecture, and I want you all to prepare your questions. I'm sure you're going to have them, but don't be shy. And we're going to have Sam from Hack Club. We're going to have Vladimir from Evil Martians. Don't see him. He's here. Oh, over there. And Alan from Cisco. Over there. Perfect. So the program is packed. I'll just mention a few very short announcements. So the first one is we received a grant from Ruby Central and Fastly. It's our first kind of monetary donation. I'm going to say I don't know what to do with all this money. But no, seriously, we're going to use it for one of the future events, and you're going to know all the details of how we're actually going to be using it. If you guys know, last year at RailsConf, I gave this special keynote talking about startups on Rails. And I'm going to be doing something very similar this year, but specifically at Tropical on Rails in São Paulo. And that's why I'm again collecting feedback from startups on Rails. And I'm going to reach out to everybody I spoke to last year and looking for the new ones. So this is the link. If you are a startup, kind of started around 3-4 years ago or later on Rails, please reach out to me. I want to talk to you. I want to hear your honest, unfiltered feedback for Rails, Ruby, and the ecosystem. And the final thing is the next meetup. It's going to be in March. It's going to be between March 10th and 20th. We don't have the date yet. So we have a few different venues that we are figuring out. So we don't have the date yet. So please make sure you're subscribed to here. Yeah, and yeah, you'll get the invitation. That's the idea. So with that, we are welcoming Joel Hawksley, the staff engineering manager, something like that. No, okay. Let me say this: the author of Vue component. This I know for sure, and some sort of engineer at GitHub.
Staff engineer.
Staff engineer.
Whatever.
What does it mean? How can you be staff engineer without being a manager? Okay, different topic.
It's a different topic. I mean, I could talk about that instead. Oh, thank you guys. Thanks, y'all. Are you guys ready to watch me figure out how to get my Mac to display up there? Hey, it's working. All right. Thank you. Thank you, everyone, for being here. It's so great to be here. Yeah, thank you for joining us here at GitHub's headquarters. It's so great to see all of you. What a good turnout. As Irina said, I'm happy to take questions during my presentation, as well as at the end. I actually almost prefer during the presentation because I'll be in the mindset of talking about that specific topic. But yeah, I want to start with gratitude. First and foremost, for everyone here. I'm so grateful for the Ruby community, and I'm really proud of what it's become, and I'm really proud to be part of it. So as a quick intro, my name's Joel. I live outside of Boulder, Colorado. This is actually a mountain bike ride from earlier this summer. This is not a stock photo. I've been building for the web for about 20 years now, with about the last decade in Ruby on Rails. Outside of work, I love to do stuff like this, going out in nature. This is actually about 5 minutes from my house, which is pretty sweet. And I love hanging out with my wife and our little 18-month-old boy, who does not go mountain biking yet. I currently work here at GitHub as a staff engineer, although I don't really work here. I work back in Colorado. Over my time here, I've worked on creating and maintaining the Vue component framework. building out our design system with a bunch of lovely folks, including Cameron, who's here and can tell you more about it. And for a little while, I helped lead our accessibility program for the company. So I've been here for about 7 years now, and I still have no plans of leaving, which feels really weird to say, given how short tenures can be in our industry. I love our culture, the problems I get to work on, and the wonderful people I get to work with. Really kind of just the same as when I joined. And I recognize how extremely privileged I am to say that. I was actually kind of curious to survey you all. How many people here, raise your hand if you've been at your job for at least a year at the same company? How about 2 years? 3? Skip to 5. 6? 8? Okay, are you hiring? You must, yeah. Where do you work? I just always think that tenure is such a great indicator of companies doing a lot of things well, right? Because we have a lot of options as engineers. And the fact that you chose to stick around, I think that, you know, maybe our workplaces have something in common. Anyways, I think that's an extremely privileged place to be, and I recognize that coming from that perspective. So today I'm going to reflect on what I've learned working on GitHub's UI architecture and what I think lies ahead for our discipline in the future. My goal here is to share our experiences so that they can help you inform similar decisions that you're going to make in your careers, hopefully different decisions. So being here for so long has really changed my perspective on being a software engineer. I think one of the greatest parts of working on a single monolithic Rails code base for so long is getting to watch the entire life cycle of your decisions. So you might take an idea to a prototype, release it internally, make it publicly available, have it widely adopted by the public, and then eventually put it on long-term support. There's so much to learn from each stage, but I think there's even more to learn from seeing a single idea go through all of those steps. And when you're switching companies, as we often do in the industry, I think you really miss out on that opportunity to learn those longer term lessons that you can apply as you go and make more engineering decisions in your career. So I'll start with the usual disclaimer. GitHub is a really big company. What I'm sharing might or might not be relevant to your specific situation. To this day, effectively all of our customer-facing traffic, correct me if I'm wrong, anyone else who works here, I think everything goes through Rails as of today. Like when you hit the API, when you hit anything that renders a view, it is going through Rails today. We have a few dozen supporting services that sit behind our monolith. We call it a Citadel architecture. And I like to always share some stats about the scale of our Rails code base and when it comes to like models, views, controllers, et cetera. And because I was going to be presenting at this big meetup, I wanted to do something better, which is I made a script that provides that data in time series. It's basically Rails stats, but what it does is it goes back in time, looks at the first commit for a repository, and then every month checks out the repository and runs Rails stats and provides time series growth metrics. So this is the growth chart of the GitHub.com monolith, starting from 2 months after inception in January of 2008. So in the red, we have the number of models. We have 5,000 of them. Yellow is the number of unique pages in the application. And blue is controllers. So we have about 2,100 of those. And green is the number of unique contributors to the monolith per month. So we're currently stable right around 650 people contributing to our Rails code base. And it could be different people every month, but that's 650 unique people per month. This script is open source. That's the URL. And I would love to hear and maybe even see some data from all of you, because I'd love to see what your trends look like in terms of even just like these like broad trends of how much surface area you expect like the average engineer like kind of per capita to be responsible for. Anyways, so with that context out of the way, today I'm going to share kind of 3 main lessons. One is that I believe native is the new baseline for UI architecture. The second is what I'm calling the UI abstraction paradox. And the third is that I believe front-end architecture crossed 10 times back-end. So first, native is the new baseline. GitHub's UI has gone through really several eras, and you can see them to this day if you were to go through our code base. I think there's probably like 5 or 6 kind of what I like to call vintages of our UI architecture. And one way to visualize this effect is a tool called Git of Theseus. Has anyone run this tool in their code base? It's so cool. So what it does is it takes all of your commits. We have 2 million in our mono repo. So like in about 100 hours on this M1 Max, gave me this graph. And this is a chart of survival for lines of code by when they are committed. So what this means is that let's just take, let's see, 2023 in the teal. We added all that code, but then by the 2 today of those lines of code, that's how many have not been changed over that time. So if you go back a couple of years, let's pick like the kind of like the dark green, 2018, you can see that of the volume we added there, about half of that code has not been changed since it's been committed. And what this really illuminated to me is that our code sticks around when we write it. You know, we aren't necessarily going back and deleting or significantly changing what has already been written. We aren't doing those refactors that we said we would do later, right? Which means that in a lot of cases, what we commit is frozen in time. And that is until we have no choice but to change it. And in my time here, we've significantly raised our standards for how we build UI, which has had the effect of making doing things the right way increasingly complex. So I've talked about this a lot previously, but we've made significant efforts to improve the accessibility of our products, working towards some level of WCAG compliance. But we've also worked really hard to improve our availability. For a long time, we accepted some amount of UI regressions as just kind of part of this, part of the equation. While we never measured how many times we shipped UI bugs, it was generally accepted that we would never catch them all, but that we would just rely on our ability to fast follow with either a rollback or a bug fix or turning off a feature flag. And it would really just be whenever we noticed something, or in this case, this is from a tweet. We did a lot of Twitter-driven development back in the day. That is no longer the case. We now consider UI bugs to be just like any other bug, and we count them against our availability scores, or at least we're trying to. Cameron is trying to help us do that. And our standards are 3 nines. So can anyone here tell me how many hours a year 3 nines of availability is? Oh, it is 8.5 hours of downtime. So our CI and deploy cycle is about half an hour, which means if you do the math, we don't have a lot of room for error when it comes to deploys. So in discussions with other peers in the industry, these availability and accessibility standards that we have are really an exception to the rule. Many companies don't prioritize them as much as we do. And what this can mean is that those who don't understand the implications of these constraints may expect us to deliver more than we do, maybe ship things more quickly, especially folks joining GitHub from other companies. But beyond accessibility and availability, there's also kind of this amorphous expectation that's been changing, which is the expectation that GitHub is more app-like. And one place you might have seen this was GitHub projects. So our customers were asking us for features well beyond what our existing implementation could do. It wasn't like, oh, can you add X, Y, Z? It's like, guys, the other project management tools in the space are way more complicated. They allow you to solve a lot more nuanced management like workflows. And more broadly, we're seeing other companies in our space innovate with more app-like experiences, both in browser, on mobile, and even inside code editors, right? Like that's becoming a new API for dev tools, which has led to us adopting React. While we don't have any plans to rewrite GitHub in React, I think a lot of people think we're just doing a wholesale rewrite. We're not. We are building most of our new experiences in React, especially when they need to be more app-like. So we made this decision a couple of years ago, and since then we've added about 250 routes that serve that render React. And you can think of these 250 routes as about half of the average pages that are used by a given user in a typical week. So this graph was also generated by that Rails history tool. It's custom to our code base, so it would need some modification to run on yours. But we've used this to track our adoption. But I think the root cause of this pressure isn't just what other companies are doing in the space. As software continues to eat the world, a new population of consumers is emerging. So according to Pew Research, 15% of US adults only access their internet through a mobile device. And various reports estimate right around 90% of that usage that's in mobile devices is in apps. It's not in the browser. So if you're using apps all day, even if all that time is actually just Instagram and YouTube, which I believe it's really just those two apps, when you go back to using the web, it's a step back because those apps are built in the native UI tooling, whether it's on Android or iOS generally. And this is actually way more stark if you broaden your perspective to beyond the United States. So for example, in India, only 22% of urban households have a computer. So most usage in India, even in urban centers, I think it's like in non-urban centers, it's like 5% adoption for computers. It's really stark. So that is all to say, I think that mobile is becoming the new baseline. And I think it's worth reflecting that we're trying to match that experience using a tech stack that was really built for displaying documents. So while the web has come a long way, it wasn't built for the ground up for building experiences that compete with the fidelity of native mobile applications. And I know that I'm not the only person in this community who has desired to keep the web the way it was, but times are changing. So I have a question for all of you. Imagine you're about to book a vacation. Would you do it using only your phone? Raise your hand if you would. Almost no one. So what I've heard is that is one of the most predictive questions as to whether you are a millennial or younger. So I'll admit that this realization snuck up on me. And I think the reason I bring this up is that it really highlighted a blind spot for me. I didn't know this was happening. And I think that based on y'all's responses, you might not know it's happening either. So given that native is the new baseline, I think it's worth considering how your app compares to the competition, especially say if they have a native mobile app, right? Our native mobile app is really popular, and I think it's a big part of our ability to stay relevant as time goes on. So of all the ideas I've really seen run through their life cycle while working here, it's design systems. So as we've raised the bar on availability and accessibility, more and more teams have looked to our design system to help them meet those standards, as they should. I mean, I don't know about what you guys think of design systems. I actually believe that's the whole point, is that you create tools that give teams leverage to meet higher and higher standards for UI quality. But it's really had the effect of putting really the hopes and dreams of many of the UI goals we have on the shoulders of only a few people. In our case, less than a dozen engineers of the 650 people working on the monolith. And you can see this pressure in the very architecture of our design system right on the homepage. So this is the Primer landing page from 2018. So Primer back then was just a library of CSS classes. You might recognize something that is very much like Bootstrap because Primer was in part created by the creator of Bootstrap. And I would say it's a less verbose version of Tailwind is one way I'd describe it. But as we look to improve the availability and accessibility of our UI, we found it necessary to encapsulate markup and behavior, not just styles, which led us, like most people, to the component abstraction. In this case, we added both React components and Vue components. But to be honest with you, it's been a real struggle to build and maintain a system that meets these high availability and accessibility standards, especially multiple implementations of it. And that's in part because I believe our design system is a victim of its own success. The more it is adopted, the harder it is to change. And our experience has been the perfect example of Hiram's law. Does anyone here know what Hiram's law is? Wow, Okay. So Hiram's law, you know what Hiram's law is, you just might not know the name for it, which is that with the sufficient number of users of an API, it does not matter what you promise in the contract. All observable behaviors of your system will be depended on by somebody. This is there's a famous XKCD for comic about this one. It's the one where like the key, the space bar heater. The space bar heater. Yeah. 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 Brandon will provide the space bar heater reference. So for example, take the lowly button. So this is simple, right? Like it's just a button. It has like 4 main states, but we use this 5,000 times. 4,000 times in Rails and 1,000 times in React code just in our monolith. And sometimes in ways that we don't anticipate or have tests for in our design system. So while we do what we can to isolate our styles, the global nature of CSS and even like the ability to hook into, say, JavaScript events makes it really difficult to have the level of confidence we need to sleep well at night when shipping even the smallest of UI changes. So what this means is that making changes to this button are harder and harder, no matter how small they are. Updating the version of Primer in GitHub.com has become increasingly stressful. Cameron, I've literally wrote this section of the talk just for you, because this is Cameron's job, and it is, I think, one of the hardest jobs at our company right now. Because while we've made strides reducing risk with tools like feature flags, we still ultimately rely on a certain amount of manual testing for really critical flows. And just to take a step back, the thing that is really hard about this is that if you compare this to similar problems on the back end, we're significantly behind when it comes to the confidence we have in our releases. But I think there's a bigger problem. Why are there so many design systems in the first place? We're all inventing solutions to the same problems, and I can't help but feel that there's a great deal of human potential being wasted on that duplication of effort. And to give you an example, here is the same button component, but from Zendesk's design system. The level of sameness, even in the documentation site, really strikes me. The UI architecture is nearly identical. I believe some of the table of contents titles are the same. So some of you might see where I'm going here, which is that I think it's time for us to consider a global design system. And I'm thankfully not alone. Brad Frost is leading an effort through one of the W3 committees, and I'd encourage you to read about his work here. He started working on this in part because his consultancy at one point was working with 3 different clients, building an accordion component for all of them at the same time. So what does this mean for you? I was recently asked by someone at RubyConf whether their company should build their own design system from scratch. They had a single designer and a couple of engineers, at least an order of magnitude smaller than the team we have here at GitHub. And here's what I told them. We can barely afford to maintain and do the work right. Even at our scale, we don't even build all of our UI ourselves. So for example, when you see our charts, that's high charts. We didn't build our charts. When you use GitHub projects, we use the React table project, or at least we did for a while. We've even toyed with the idea of theming an existing design system off the shelf like Radix or Shoelace when we need to implement a new complex pattern, instead of actually building every new component ourselves. So that is to say, I believe the UI abstraction paradox is real. Beware the cost of Beware the cost of reinventing the wheel, and try and reuse existing design systems whenever possible. So one of my favorite series of articles is the Falsehoods Programmers Believe About X. Has anyone seen these articles? Oh, I see some nodding. Yeah, they're good. These are a good one to share around work. So for example, the one on time is one of my favorite ones. I think that I looked at this list and I'm like, I've dealt with every single one of those bugs. Names is a good one too. For example, people's names do not change. People's names are case insensitive. And in my research for this talk, I actually found out that there's an awesome list called Awesome Falsehoods. But I looked and it was missing a really important article, which is Falsehoods Programmers Believe About UI. But I found it, and it's not called that, but it's this article by Dave Rupert called UI's F of states raised to the N. And Rupert in this article elaborates on the dozens of runtime inputs that can affect how UI renders, many of which are outside of our control as our developers. So for example, browser extensions can change how your code runs. I would guess that a quarter of the UI bugs that my team has fielded at GitHub have actually just been browser extensions. They have not been our code. And that's probably even a little low. And this is madness coming from the backend world, right? Like we write Ruby, like we run all of github.com on a single version of Ruby. But our HTML, CSS, and JavaScript run on several major versions of each major browser across a matrix of possible hardware stacks. And that through the depth of those, like I think we do 3 major versions back at this point. So you'd think that was such a massive difference in runtime complexity, right? Like we have one Ruby target and we have how many front-end targets? Is that like 100? You would think that was such a difference in complexity that we would test our front-end code as thoroughly as our back-end code, right? Right? Does anyone here feel like they test their front-end code as thoroughly as their back-end code? So for one, I think we all know that browser tests tend to be slow and they tend to be flaky compared to our backend unit tests. But it's also more structural. Like our backend code is more testable than our front end code. Before we had components, we really didn't even have an abstraction to test that wasn't the entire page. So we wrote our tests, like that at the system level. But thankfully, with component-driven UI, we're quickly turning the corner on this issue. In fact, when we adopted View Component at GitHub, I think one of the smartest things we did is we had a linter that required you to write a test every time you created a View component, and it basically solved the problem. But that isn't enough due to how varied the front-end runtime can be. Think about the amount of tooling and research around making perfect backend code. For example, we can, for a bit of math, prove that mission-critical systems such as like avionics and Amazon's S3 are immune from certain failure modes. This is literally how S3 gets to like 10 nines of durability, is that they have mathematical proof that they are 10 nines durable. So in my research, there are little to no robust guarantees or any work being done on formal methods for the front end. The one I could find was formal verification that a cookie banner was shown. So as our application grows, so does the amount of front-end complexity that we have to manage. So here's some more graphs from the Rails history tool. On the top here, we have the chart from earlier on React adoption and number of routes. And on the bottom, we have the number of front-end lines of code divided by the number of contributing engineers to our code base. So if you look at these graphs, the number of lines of code was really stable for about a decade, until we started adopting React. So for front-end lines of code, this is summing up like CSS, SCSS, Vue components, ERB, JavaScript, TypeScript, excluding tests. This is just the actual implementation. And this sign is concerning to me. Wouldn't we expect our UI code to become less complex over time, given the ability, given the availability of better abstractions and maybe increasingly usable design systems? One contributing factor I've observed here is that design is not bound by the same constraints as engineering. There really is an imbalance in change cost between engineering and design. So for example, I've seen designers quickly put together in about a week what would take me a year to build as an engineer. And honestly, they could probably do it in a day or an hour. We have designs from 4 years ago that we're still working to implement, which is great because they were really aspirational and really beautiful. But because there are a few natural limits, it's easy to build designs that are difficult to implement. But the reality for us is a lot more subtle. It's actually really uncommon for us to intend to deviate from our design system. But because we're designing in an environment that is removed from our target medium, in our case, we're using Figma, there's no guarantee that what is designed can be built with our component libraries, at least without compromises. So I really see an opportunity here for us in our practices to start building our prototypes with our components instead of using a design tool like Figma, as it would kind of eliminate that mapping gap between the disciplines. But I believe we're most successful when we really think about our UI complexity as something that we budget for and allocate for when it's most necessary. So for us, this might be something like diffs or 4-dimensional drag and drop. or the merge box. I would argue that this is the single most complex part of GitHub. And we recently rewrote it in React. These kinds of unique UIs have a lot less convention. Like how many merge boxes do you see on the internet? And they have unique accessibility characteristics because they are less conventional. And those characteristics can be really expensive to solve. But a lot of the time, I think our budget should be zero. We should build with something that already exists, something we've already built or someone else has built. And I think our customers would actually prefer that. The people who use the software we build are likely interacting with dozens of other apps in a given day. Do we really want to expect people to relearn to do the same thing differently every time they pick up a new app? So, imagine if the car world worked this way. Like if every time you got in a car, you had to figure out where the accelerator was. It'd be madness. And I can give you an example of this. E-commerce checkouts. So like this is just 3 that I used in 1 week when I was working on this talk. Why is there more than one way for me to provide a shipping address in the United States? Was this one case where like Shopify becoming like the root of a lot of non-Amazon e-commerce has been really great for me as a consumer because I don't have to like learn all these new UIs and the nuances of filling them out. Imagine what this is like for someone who's using assistive technology and is getting wildly different signals, say with their screen reader. And honestly, I've had to fight with my inner artist to view everything as art. I'm actually a photographer by training. Because what we're really building here as engineers is tools. We're not building art. I think art is a great way to express your creativity, but it shouldn't be prioritized over usability. What's really exhausting to me about this problem is that things could not be more different on the back end, right? Like we regularly use and improve libraries that already exist. It's the reason we're all here in this room because we like Ruby and Rails and we work to improve them. And as Rubyists, I think we are really good at working together to improve open source software. We contribute changes back to Rails based on our experiences using it. And I think the same should be true about UI frameworks and even browsers themselves. And one person I like to highlight in the space is my colleague Keith, who worked to improve browsers to the point of enabling us to remove custom code from our code base. In just the last 18 months, he's landed 100 patches in 5 different browsers. I know this is a little extreme, but you can do it too. You can land changes to Chrome. But besides that, what can you do? I'd recommend thinking about UI complexity as something to budget for and then spend it wisely, only inventing as little as absolutely possible. Because if there's any lesson I learned in working on GitHub's UI architecture, is that the equivalent amount of code complexity costs 10 times as much on the front end as on the back end in the long run. So in conclusion, native is the new baseline. Consider how your app compares to your competition, especially their native app experience. The UI abstraction paradox is real. Beware the cost of reinventing the wheel and reuse existing design systems whenever you can. And front end costs 10 times back end, so budget accordingly. Thank you. And thank you to my peers, Francis, Jonathan, and Josh, who helped review this work. I also should note we are hiring. We have open roles in UI engineering, both on design systems and accessibility. And they are a little bit, I think, Cameron, they're what, level 2? Yeah, so they're level 2 positions, which is one step above, right, new grad. So really excited about that. We also have an open principal engineer role for UI engineering. So if you are a React expert, we want to talk. Anyways, questions? Do we have time for questions? Yeah. You have a question?
Yeah, I have a question.
Yeah.
So did you grow to like React?
Did I what?
Did you grow? Did React grow on you? Did you?
Oh, did React?
Yeah.
So you asked, did React grow on me? I mean, yeah. Because the focus on DX is ridiculous, right? Like, you'll know someone uses React because they'll tell you, And that's powerful, right? I mean, it's the same thing about Rails, right? Like people know we use Rails because we tell them we use Rails. And I think that's really compelling. I mean, I can be honest with you, the whole reason I created Vue components is because I was jealous, right? Like we were losing out on a lot of the benefits of component-driven UI, and we couldn't afford to migrate, still can't afford to migrate our 4,000 routes to be to be in React. So we wanted a way to get a lot of those benefits, whether it was being able to test them in isolation or, a lot of the other benefits you get from the component architectures. Yeah. Yeah.
Yeah. Okay. Okay. I know. I just know folks ask each other this question. When should we go? When should we reach? I know. Okay. At GitHub, you guys' team, right? It's like a platform team, right? So you're kind of creating tools for other teams, right? So, but you kind of can see how they are making decisions. So I'm wondering, do you have some kind of guidelines on when to reach for React and when to reach for Vue component?
Yeah, the question was, what is our guidance? And I think that this is it's specific to us, but the question is like, what is our guidance for reaching to React or Vue component? And really, we're shifting more and more in the direction of saying we're going to support the React platform more than Rails, because we view it as kind of a superset in its capabilities, that it's able to handle both the app-like experiences and the ones that are more static. So it's easier to have one tool than have to maintain two. But we have a lot of legacy code, so I don't see that like drastically changing over the long term in terms of support. Often it comes down to team comfort. So if you have a team that's a lot of folks that have really only written React front ends, they often pick React and vice versa. Yeah.
That's okay. Okay, you can find. Okay.
And then I'll repeat it. Yeah.
We've seen a lot of improvement in Hotwire and Hotwire native. Have you taken a look and maybe tried to take a component that you felt needed to be built in React in the past and rebuilt it in Hotwire and Hotwire native today as a comparison to see where you can use Hotwire instead, which gives you access to new components,
right?
All of those types of things.
Sure. So the question is have we tested the viability of Hotwire lately? We use Hotwire. I tried to avoid having this talk being why we are using React, because the answers are honestly mostly non-technical versus technical. It, in a lot of cases, comes down to the fact that we have a lot of people with React experience at the company, and that it has made more sense to allow them to work in an environment where they're comfortable. That has mattered more than technical capabilities. I think that that's like such a paradox of software architectures that often the decisions aren't technical. I don't know if that's a satisfying answer to you. I think that it's not a satisfying answer. I think that like kind of my read on the situation though is that what I'm trying to get across with my comments about like native experience is that like this is where Rails is doing the right thing, which is enabling teams to build hybrid mobile apps that can get closer in that level of fidelity without a lot of investment in terms of people.
But as I understand it, React native, nothing like that. Whereas Hotwire native, it's a lot of power.
Right. So your statement is that is kind of weighing React Native versus Hotwire. So we are not using React Native. We do full native. I have opinions on that, but I don't work on that team, so I'd rather not share them publicly. Yeah. Yeah, your question is React Native.
Yeah. When you say React Native,
I'm strictly talking about web UI in this circumstance. Yeah. In fact, I think that that's kind of something I left out of my talk, is that to a certain extent, we've been receiving pressure to make GitHub.com more app-like from ourselves, which is that our mobile app is fantastic. Our mobile team does a great job. And in some situations, they're able to build experiences that are more dynamic and engaging for our customers than we're able to do on .com.
Well, when you say React, you have a choice of React that you like show.
Oh, sure.
Flavor of React.
What flavor of React? Yeah. How is GitHub doing React? The meta question I've been having is, can we find a way to all agree? Because the thing that like really wears me down is how many flavors there are and the varying degrees of portability. Like I think when I picked up Rails, I did not appreciate what the word convention really meant. Convention means that like you can go to another Rails shop and be productive. And I would love to feel that way on the front end. I think we all would. I think even folks across the non-React world would love to feel that way, that we could agree on something. The decision fatigue, exactly. Yeah, so we don't do Next.js. We've looked at it, but we have our own bespoke SSR layer. Again, I'm not as involved in that piece, so I can't speak in too much detail, but. Yeah.
Yeah, I can get to that.
I just have a two-part question. So I remember Scriptaculous and CoffeeScript and
Oh yeah, that
hosting a
was one of
backbone
those eras,
CoffeeScript
right?
thing.
Yeah.
And I feel like those things were the abstraction we could imagine at the time, and then things have been created. So the first question is like, how do you kind of think about always being able to tear things down and rebuild them and getting input, getting the correct input? And then the second part of the question is like, there's this story about how Steve Jobs one point ripped apart Final Cut Pro and made it look like iMovie, and he was going to piss off all the industry people, but he wanted to build something that people didn't understand yet. How do you kind of like fill in your blind spots and then make great decisions about building for the future?
Okay, so blind spots and building for the future, and your first question was
like how do you
how do you handle
maybe you're building this thing that you love because you built it, but it's going to be this thing that 10 years from now you look back and think, oh, I just didn't
I mean,
think.
what have you ever written code that you didn't feel that way about?
Or are you planning for it?
I mean, I think you kind of have to assume that it's going to happen a lot sooner than 10 years. I think that the kind of what you were alluding to a second ago with the change fatigue with React is that 10 years is maybe more like 2 or 3. And I think that the way I think about it is the testing layer. Like, do you have enough testing confidence that you could actually change your system? And I'd say the jury's out on that one. I haven't seen across my career a front-end code base that I was as confident changing as it should have been. And that's kind of what we see is that, like even with backend systems, you end up solving that solution through rewrites more than you should. Because by the time you were to actually capture all the potential states of a front-end system, you basically have built a new one.
So always building for the future. All right, thank you.
Yeah, and you had a second question though.
No, that was the two questions. Like,
okay, that answered it both. Okay,
how do you how do you decide it's time to rip down? And I guess a related analogy is, I feel like I'm familiar with Google Cloud and AWS, and I've seen Azure, and I feel like it's not for me, but I use Azure all the time through GitHub Actions. And so there's a choice to like build something for people, but the people you're building for might all die of old age, and there'll be this group of people who only use phones. So
I think I get what you're asking, and I think that is kind of the actual whole point of this talk, which is that your front-end complexity is going to cost you a lot more in the long run, so you should do less of it. So I think that's actually the best answer, is that your UI should be way simpler than you think architecturally, because you're going to really pay for it down the road. Now, I see that from a company that is sticking around, right? Like the paradox of this is that if you're at a startup, you probably don't want to over-engineer things too much, but I think that actually makes the case stronger for using something off the shelf.
Can I ask another one?
Yeah. You have time?
You guys should check. Yeah. So about the future, by the way, about the future. So you guys are thinking about, kind of like this next billion of internet users. So those are people in countries where they don't have access to laptops, computers, and also they don't have access to like stable internet connection.
Right.
So kind of broadband. And so how are you guys thinking about negating that and things like optimistic UI or local first or
oh, sure. So
Yeah,
like what architectures do we think are necessary as we like think about like say doubling or quadrupling our user base?
Yeah, and for the audience, like this is all about kind of keeping the kind of instantly reactive UI,
right,
while the requests to server are not yet going through.
I mean, one of the things we architecturally do is that we have points of presence around the world. So like, for example, a long time ago, if you were in Australia, your experience on GitHub was very different than if you were in the United States. due to the speed of light and distance. But now we have points of presence around the world that negate that factor. So like that's like a infrastructure thing we do. In terms of like front end architecture, I don't think we've really gone too far in that direction. And in fact, I think that to a certain extent, some of our mindset is that our mobile app can serve that purpose. It's not going to be it's not going to do that job perfectly, but like to a certain extent, the architectures are in place, you know, versus having to, you know, and they're coming to the browser, but they're, you know, that's a new thing. And, you know, we're looking at three versions back, right? That's the other caveat for a lot of this stuff is that we support so many major versions back that while we do write polyfills whenever we can, that kind of limits our ability to use some of those bleeding edge things.
Yeah, I think what I'm trying to get to is maybe specifically for the hotwire ecosystem, we kind of don't have a lot of optimistic kind of tooling. Maybe GitHub can come up with that.
Well, and I think that like, so there's kind of this question. I think that like there's a relevant piece here, which is that in the Ruby community, we've really benefited by the fact that computers have gotten a lot faster and cheaper as Ruby's become more popular. So like we haven't had to make Ruby like amazingly faster for it to remain a competitive tool. So what I would wonder is whether mobile networks and devices are going to get better faster than our ability to serve them in an offline first capacity will. I would guess that they'll meet in the middle at some point, but I would guess that the broadband networks at the rate they're going will get there faster and we won't actually need as much of it. That's my guess though.
Yep.
Okay.
I think unless you're somewhere in San Francisco where it's not really, there's no really reception at some places here around here.
Yeah.
Anyway.
How do you decide whether you're going to build in React versus Vue component or not?
So the question is, how do you decide whether to use React or Vue component? Can you be more specific? Because I think I answered that question generally earlier. Is there a specific thing you're curious about?
Well, you're building a Vue component like a library or a Juniper. I guess I'm thinking about more complex applications than just the component.
Sure.
How do you decide whether you're going to build React?
Yeah, maybe Joel, how about this? You already answered that your guidance is React, but how about we abstract from GitHub for a sec and you think about any other company?
Sure. So I think that I can tell you where where I've actually seen that play out practically for us in a way that I think that is useful to you, which is that it's all about state management. So if you want to manage a lot of state change on the front end, that's where I've seen like we have some people who are really good at web components and they can pull it off, but that ability is less common versus like if you look at like the React ecosystem, there are a lot of answers for managing complex state that I don't have any that I'm a particular fan of, but they are out there and they can help you accomplish those goals. So I think that is actually the clearest criteria for us is like, if you want to do something really dynamic on the front end, that's what really drives the requirement to use it versus like a team by team preference.
All right. Seems like we can again say thank you to Joel.
Yeah, we can chat after too. Thank you all.
Yeah, so we will have a break after the second talk today. So we'll be able to talk more and discuss maybe some questions that some people were too shy to ask publicly. And our next speaker is Sam Potter from Hack Club. And Hack Club is this absolutely amazing thing. It's a nonprofit community of high school builders, high school makers, right? Let me make a little parallel here with GitHub. So apparently, one of the co-founders of GitHub is on the board of Hack Club, and he also made like a $500,000 donation to Hack Club. So there's this amazing kind of connection, very direct connection from GitHub to Hack Club. But I think what's super amazing, by the way, you guys could have guessed it, but I have a vision for this for this meetup, which is to always have speakers from big Rails organizations and Ruby organizations and speakers from me and smaller and just a little bit more energetic and, that stuff like that. And this is exactly what Hack Club is. So thanks so much for speaking today, Sam. Yeah, take it away.
All right. So hi, my name is Sam. As was already mentioned, I work at a place called Hack Club, and we have tried to basically build a bank using Ruby on Rails. And I guess today I'm just going to tell the story and why we did it. So yeah. Hi, I'm Sam. I'm an engineer at HCB, which is what we call the product. I'm also a CS and linguistics student at Berkeley. And in my free time, I enjoy hackathons, my bike, and public transit. On the right, that's me dressed up as a Clipper card reader for Halloween, whilst my friend was a Clipper card. So they beeped when we touched, so it's great. So what's HCB? Oh, I'm actually going to briefly do this where I can see the notes that I wrote for myself. Let's see. Cool. All right. HCB is a fiscal sponsorship program. So what that means is we, as a registered nonprofit, can allow other projects to come in and essentially piggyback off of our nonprofit status. So say, for example, you wanted to start a Ruby meetup in SF and you didn't have a legal entity or a bank account. Instead of having to use your personal bank account, you come to us and we could provide you with nonprofit status within 24 hours and also a UI for managing all your finances. And then we'll handle your taxes, your audits, etc. This is how a surprising amount of nonprofits in the US actually operate and how Hack Club itself started. We were fiscally sponsored by Makerspace here in SF. The name HCB is a little jank. Originally, this was called Hack Club Bank. We are legally not a bank. We're technically a financial services nonprofit. So that's why we've had to rebrand as we've grown. But that's where the name comes from. And what I spend most of my time on is I work as part of a team that builds a platform similar to Mercury and other neobanks for people to access their funds. You can see on there the ledger, issue credit cards, raise money, attract donations, etc. And why do we create this product in the first place? So as you heard, Hack Club is an educational nonprofit. Our primary goal is to support high school programmers, high school programming clubs, and high school hackathons. Now, if you're organizing a high school hackathon, it's actually pretty difficult, especially as a teenager. I did this myself. It's hard to get a bank account. It's hard to convince people to donate. Nonprofit status is something that often people require before they donate. That way they can get tax benefits and stuff. So we built this tool as something that high schoolers could use to organize their own high school hackathons. And that's personally how I learned about Hack Club Bank. I started as a hackathon organizer who built it, ran hackathons on it. And then when I moved to over here for university, I had access to the code base. I just started submitting PRs. And then one day I was the 1 week I was the person who submitted the most PRs, even though I was just doing it for fun. And from there I got a job. So that's pretty nice. So I guess I'm going to start with running through our banking stack. Most of our stuff nowadays runs through a platform called Column. It's a developer-focused bank with a really good API and webhooks and everything you could want. We then also do use SVB. They're the bank account we have used for years. About 6 now, I think. We used them before and after the crash. There's this wonderful article in the Vermont News about our scramble to get our funds out of SVB when it did crash. We're a nonprofit based in Vermont. So that's another fact about us. So we store our funds long-term in SVB. We have a sweep account with them. We earn interest through them. It's wonderful. their interest rates have gone up substantially after the crash. So if anyone's looking for a good interest rate, SVB is a good option. And then we use Stripe for card payments, invoices, and we are able to issue cards through Stripe as well. So we have one account with each of these banks or like financial platforms because we're one legal entity. So every project that runs on Hackler Bank will share these 3 accounts that we have. Which is the big problem that which is why we need something called the transaction engine. So this is what I spend nowadays most of my time working on. Essentially, those 2 banks plus Stripe generate statements with transactions, and we need to convert those bank statements into database records. It's important that we have a one-to-one mapping here between everything that's on our bank statements and transactions that are present on the platform. And because projects share those underlying bank accounts, it's important that we have a way of mapping transactions to projects so that each project has their own dedicated pool of funds that they can pull from and add to. So where we start is with importing transactions. So here we can kind of run through the list. Through Column, they have an API. It's awesome. Through Stripe issuing, we can use webhooks. Equally awesome. Our SVB account, we sync through Plaid, which works. And our SVB sweep account, which is where we earn all that interest, we're currently importing transactions by me going in, downloading a CSV, and then manually turning it into database records, which is a bit of a nightmare. So Stripe is instant, and Plaid and Column are performed by nightly jobs. A key principle of this design is that there has to be a one-to-one mapping between transactions in our database and transactions on our bank statement. This is because our accountants solely work with the bank statements to put together like our annual documents on QuickBooks. And so those bank statements are considered the one ultimate source of truth. So my job is to make sure that everything I write at least gets recorded on the bank statement. And this is also helpful for general auditing. So once we have these transactions in the database, we now have to map them to an organization. And there are a couple ways we've solved this problem. One is just simply unique identifiers in the transaction memo. So if you see here, each of these has HCB dash and then 6 random characters. This is just pulled from our column. And those map automatically. Another one is that Column is, fortunately with Column, we can create multiple account numbers for the same bank account. So we can also use that. So we issue every organization a unique account number, and we can use that to figure out where the money was sent to or where it originated from. For Stripe, we associate Stripe cards with an event ID, and we can then work that out from the Stripe card, the metadata in the Stripe transaction. And if it does come to it, we do have to map transactions manually quite often. Examples of this are donation matches. Occasionally we will receive a check. So we also handle manual mapping. Now this system, it kind of works, but it isn't perfect. And I guess I wanted to demonstrate this through one example. If someone wants to transfer money from one project to another project on our platform, this is a bit of a problem because the money actually won't be really moving anywhere. So there won't be any record in the bank statement. So what we've had to instead do is we opened a second account, which we purely use. We send money to it, and the moment money goes into it, we pull it right back out. And that way we have 2 transactions on the bank statement that we can then map. So that's the sort of thing, those are the sort of problems that we have to solve on a day-to-day. Now, credit cards. They break the system in so many ways. It's kind of unbelievable. But I wanted to talk about that for a bit. So if you all have ever swiped your credit card and you'll notice on whatever app you use, it'll say the transaction is pending or something. This is a real problem for us. because those transactions don't actually appear on our bank statements immediately. They take a couple of days to settle. Instead, what those are is there's something called an authorization. That's essentially permission for the merchant to charge the card, but it doesn't represent a transaction, and it can change. So what we've had to do is we've had to introduce a concept of pending transactions, because we can't authorize people to say someone had $500 in an account and they get 6 authorizations of $100. That will take them over their limit once all those authorizations settle to transactions. So here comes the concept of a pending transaction, where these ones don't have to be in our bank statements. Instead, they're a record in the database where we expect something to happen, but we don't know what it'll look like exactly yet. So we affect the balance. So we reduce the balance for these as well. So when you have an authorization, your balance immediately drops. But this can still be dangerous, and this is the #1 cause of negative balances, which is obviously a problem, because if you're having negative balances, that means money's kind of gone missing. So there are many ways that you can get to a negative balance, and here are some of my favorite ones. One is overcapture. So if you've ever been to a restaurant and you spend $20 on something and you tip $5, the authorization is often for the $20, but not for the $5 tip. So later on, you'll prove the $20 authorization, but then it'll settle as a $25 transaction. And if you only had $20 in your bank account, now you're at -5. So that's one way that you can get a negative balance. You can also have this thing happen called multi-capture, where merchants can reuse an authorization as permission. United Airlines is the #1 person to do, like the #1 organization that does this, and it has caused many bugs on our platform before. So that's another way. And then what's really scary is something called a force capture. So force captures, essentially, merchants can bypass any authorization and brute force money out of your account. So this is the reason this exists is because, well, the example I've heard is the airline example. In the air, you don't have Wi-Fi. So if you swiped your card, there'd be no way to connect to the bank to get an authorization. But people want to be able to, buy snacks on a plane. So airlines have adopted force capture, which is a way that without any sort of authorization or anything, you can forcefully capture money, and that will just appear on our bank statement. And we have no way of saying yes or no to that transaction. This has also caused many issues. Specifically in Singapore, where I grew up, the bus, when you tapped on a bus, it would force capture, which meant that I accidentally tapped a card once, and that caused an account to go negative. So, but you live and you learn. Now, enough about accounts going negative. This base infrastructure has allowed us to build some really amazing things. And I just kind of wanted to spend some time running through the cool things you can do once you've built up an infrastructure like this. One example is last year, Ian's another engineer on our team, we built out our whole version of reimbursements. So if you ever used Expensify, we essentially, the two of us, built our own version of Expensify. You can text it receipts, you can upload receipts on the web, you can get reimbursed by check, ACH, wire, PayPal, everything. And by having that lower level infrastructure to be able to send payments and stuff, this was really doable for us and was an absolute joy. Another one is cash withdrawals. These are photos. I was in Vermont at the time at I stayed up late. It was about 9:50. This convenience store was about to close because everything closes early in Vermont. And I ran there like a crazy person, pulled out my card and stuck it in, trying to withdraw cash. I don't know what the lady thought of me, but anyway, this is the first time we ever got cash out of a HCB card. And it's another example of when having some sort of credit card issuing infrastructure, you can then build these things on top of that really easily. And they actually just work exactly like standard credit card authorizations, which is kind of cool. And yeah, I still have that $20 bill, so I'm proud of that. Over the past year, we've gone from just having ACHs and mailed checks to also supporting international wires and PayPal transfers. These are other things that we've been able to use Columns APIs to build on top of. And yeah, wires are a really interesting case. Here, I can probably pull this up. Oh, okay. This is risky. Here's our code base, but I'm going to go into we're open sourcing it soon, so I'm allowed to do this. I'm going to go into the wire model down here, and we have to deal with so many edge cases with wires. These are all the different things we have to collect for different countries. Oh, I'll try making it bigger. Okay. Yeah. Here we go. So you can see there are many different types, and each of these you have to validate them in different ways. So this is one of the things that, yeah, we learned, and we actually had a funny case. There are these things called purpose codes with wires, and we sent some wires to India when we first launched this feature. So much so that Column ended up banning certain purpose codes from being used because we just didn't know how to use them correctly. So you just learn different things about different countries' systems, which is, kind of cool. Through Stripe, we've done donations and invoicing. These are pretty standard Stripe features. And then through Column, depositing checks. So if you've ever deposited a check on like Chase or something, we've done a similar thing. And as I mentioned earlier, account numbers, I faked these. So if my boss is watching, don't worry, I have not leaked data. Yeah. And now, I guess, building these things, I've learned some handy things along the way, and I just wanted to share some of the things. This was very much inspired by GitHub, but if you've ever responded to a comment on a GitHub pull request, we were inspired by that to have a shot at building this ourselves. And you can actually use the wildcard routing in Action Mailbox to hide an ID in the comment of a email address. So if you look up there, it's receipts and then plus, and then that's a random ID. So you can use that to uniquely identify what email they're responding to and route whatever their response is. So you can upload receipts now by responding to an email, or you can comment on something by responding to an email notification about a comment. Polymorphic associations was something I never knew about before writing Rails, but it's now became one of my favorite things to do. And then turbo streams via action cable. This was something that we got really into in August and basically added it everywhere we could in the app. And I'll come back to the code, but I'll just quickly show what you can do with it for anyone who hasn't seen. Hopefully this plays. So I'm typing a comment out on the left. And if I could type faster. Peers on the right. And then it'll appear on the left. This is something we got really into, and it's a lot of fun to add, and it is simply 2 lines of code. So if you add that top line to your ERB and then the bottom line to your model, it will, you don't have to worry about the was touch stuff. That was to handle a weird bug. But if you add those to your model, it will update live, which is kind of cool. Another one of my favorites was we built out this activity log over the summer. So you can see different things that are going on the platform. There's this wonderful gem called public activity, which we used that I wanted to give a shout out to. And again, it's only adding a couple of lines to the model. That's pretty fun. And then another favorite of mine that I'm pretty proud of is infinite scrolling with turbo streams. I'm going to show a demo of it and then go back to the code. Ignore the random words I type in when I'm testing. But you can see it's infinite scroll. But what we've done is basically we have here this turbo frame tag that lazy loads when you scroll down to it. And what its response includes is another turbo frame tag that lazy loads when you scroll down to it. So you keep getting more of these turbo frame tags until there's nothing more to load. And that's how we implemented infinite scrolling. Cool. But lastly, I just want to touch on the most rewarding part of this job, which is seeing what people use HackleBank for. Firstly, hackathons. This is a hackathon just down in Los Altos. I got the chance to go and be a mentor there. It's a high school hackathon, and without me ever prompting them or even mentioning what my job was, they started talking about HackleBank and how wonderful it was. They specifically talked about reimbursements, and that was something that's really meaningful. It's just nice to see people being able to achieve really impressive things using what you built. Recently, we've been working with more mutual aid groups and like community support groups, and we almost had our server crash after Ariana Grande shared a link to a org that runs on HackleBank called Mutual Aid LA when they were doing some really great work during the fires. And this was work that I didn't even know existed until I got a text about a bunch of warnings about our database load. And yeah, it's been really incredible to hear stories of how they've been able to go out and achieve things using the platform we provide. More closer to home, I guess, or I guess something that I'm more experienced with is robotics teams. They're big users. They spend so much money. They have to raise so much money. So we support them as well. Advocacy groups are another one. They've gotten really big on our platform, and there's so much more. And it's really meaningful for me, at least, to be able to go and talk to these people and hear how what I'm building helps them, and then to be able to go home and stay up all night building the feature they request, and then seeing them use that the next day. So that's really nice. And lastly, I did want to mention we are working towards this goal we have of open sourcing finances. This is an example of hackathon. It's a hackathon I ran. Its finances are entirely open source. If you are curious, you can head to that link and it will send you to a read-only version of our platform where you can see how someone else organized a hackathon, what they'd spend money on. And this is something that we hope more nonprofits will adopt. We open source all of our finances because we want people to be able to see how you can go about doing things. And in that spirit, we are also working on open sourcing HCB. Unfortunately, many years ago, there's a testing file with our bank account numbers committed in it that I need to go through every fork of the repo to wipe it from because we'd prefer not to lose the money in that account. But after that, we are going to open source HCB. And I'm really looking forward to that because I'm really excited to share all the work that we've been doing for the past couple of years. So yeah, thank you. And I wanted to give a special shout out to everyone on the team. Over the years, there's about 5 of us working on it right now, but over the years, 53 people have contributed to this code base. And I want to give them a shout out for all the great work they've done because yeah, it would be impossible to do all this work without them. So yeah, thank you for listening. And yeah, if anyone has any questions, I'd be happy to answer them.
That was pretty amazing. I'm profoundly inspired. I know you all are.
I assume you've seen Zelle. Can you give me a quick what space are they filling in? Because I think we all know PayPal, but Zelle seems to be the new way to write checks.
We would love to be able to support Zelle. It's been something I've been trying to work on. Zelle is very closely tied up with like just your standard American banks. So how we do PayPal, for example, is we actually have someone who manually sends the PayPal transactions. And we haven't figured out how to do this for Zelle. there's also a gray area of whether you can use it for commercial purposes that we have to figure out. And I've tried accessing the API, and that is no luck at all. But yeah.
Okay, just a sec.
Great presentation. I just wanted to ask, can you walk us through the process of onboarding a new nonprofit or user onto the platform, especially like the order of relations in the database? Like first is entity, then account, then transactions, and like how does that work?
Okay, yeah, sure. So you start off with someone as a user, and then we create. I'm going to call it an event because that's what the database model is used. It calls it because it was built for hackathons. So we then, the moment someone applies on our website, we create an event in like demo mode for them, which is a read-only mode essentially. And then they have to sign a contract. So we now do send those contracts out through the platform. Previously, we just used DocuSign, but we now integrate with a product called DocuSeal's API to send them a contract. Once they've signed that contract, we upload that, and that gives them like the legal status once they've signed the contract, and then we activate their account. So now you have an event with a couple of users in it. And then they can create cards, which would then start producing transactions if they spent with them, or someone could send them money through like the account number. That would also produce a transaction. Yeah, it's kind of what it looks like, if that makes sense. Oh, yes. So they are, the accounts are created automatically, but we manually jump on a call with every user every organization we onboard to walk them through the process. We also, by doing the fiscal sponsorship stuff, we take on the responsibility of like making sure they are doing nonprofit work. So we have a call with them to gauge that. Yeah.
Okay, I'm curious about something. Can you share your Rails story with us? I'm just got curious.
Oh yeah. So I kind of briefly mentioned this, but I was someone who I programmed in React a lot, and I'd organized hackathons. I'd used Hackler Bank, and I had a long running list of features that I wanted, and I guess I ended up becoming impatient and decided that I would try my hand at building those features myself. So I ended up making a bunch of PRs that built out random things. I think the first PR I ever made was it added like a link to the phone number at the bottom. But then I went on to build some other things. So I just totally learned by doing it and just trying to make this thing better. But now I've gone on to build some other Rails projects for fun because I do actually enjoy it now. There at the start, I will admit that I was not the biggest fan of Rails. I found it very confusing, but I figured it out.
So in my interactions with financial systems, I've always found fraud to be very interesting. Do you have any good fraud stories?
Many.
Could you tell us one?
So what's a good example of one? We give out grants a lot. So we give out grants through the platform. Many people will go on and try and spend these grants at other places for purposes that they aren't meant to. For example, buying Amazon gift cards and stuff. That's a common one. I'm trying to think of a case where someone did something absolutely crazy.
Okay, so let's take that example. How do you handle that in your system?
Oh, yes. So that led to us building a whole new feature. So we built out something called card grants, which essentially provide a merchant lock on a singular card. So it basically means we can find someone, send them a card, and then we can lock that card to specific merchant IDs. So this is what one of them looks like. In theory, this will not show any numbers. So someone can get a card like this. It'll be locked to, say, JLC PCB. and that way we can kind of cut down on that. But even then, people find ways around this. And yeah, we added regex keyword locks, which I'm now very scared of someone finding a way around. Yeah,
Thank you.
no worries.
So now when you're open source and all of that, of course, it's gonna get much easier. Yeah. No pressure. No pressure. Don't worry. It's gonna go great. By the way, Joel, I thought you're gonna ask about UI. No. Gonna ask that now. No, okay. What's the Hack Club's stack, and maybe specifically on the UI side?
Yeah, so we started using Rails. Sorry, React. Wrong word. Starts with the same letter. We started using React recently, but most of it is really messy ERB code right now. No components. Some helpers that will generate we have like a helper that will generate the avatar, but beyond that, it is mostly just messy ERB code. And then I did add a fair bit of React to the code base. Like we added, if any of you have ever seen those like Command K windows, we added one of those. That's an example of something we use React for. Yeah.
Yeah. So, but by the way, so the other side of open sourcing this code base is that hopefully somebody will get inspired to propose some cool changes to the code base.
Hopefully, yeah.
Yeah. The questions.
So dealing with financial institutions are born and they die and they change, and your system has to kind of take that into account. So in your database, how do you handle banks that go away? For instance, if you're going to create a new account, you need to have like the right routing number, right account number. How do you handle changes in the external system of the world finance?
Yeah, so our model, the way we've structured our database is we have a series of like what we call raw transactions, which is what we get from the bank. So for example, we have something called like a raw column transaction. We have a raw stripe transaction. These are specifically designed for each of those types of bank, or each like platform we use. So SVB has one as well. But then on top of that, we have a model called canonical transaction, which is just a general purpose model. And most of our stuff builds from that. So when, for example, we have a stripe transaction or a column transaction, they'll both create something called a canonical transaction. And then that's what we build the ledger from. So we've tried to make it flexible enough that we can switch providers. We've switched from SVB to something called increase, and then afterwards something called column. So we've gotten somewhat good at switching providers. And yeah, that's kind of how it works.
I enjoyed hearing all the edge cases that can lead to negative account balances.
Yeah.
How do those get resolved eventually?
Often we have an operating fund. Often we end up just topping up the organization and taking the loss. We have had people donate back, but normally it's like $3 or something like that. So we just cover the loss. Yeah.
Thank you all. So we are kind of running out of time for this. So let's thank Sam again for amazing presentation. Hope to hear more from Hack Club at Ruby later. And we're gonna go into the break now. And after the break, we're gonna have this super exciting part where you are all gonna be here. Okay, some of you. So it's gonna be the open mic. The open mic is for you to make any sort of announcements, questions, shout outs, anything. You might be looking for a job, hiring, I don't know, you found the new jam that you really like, want to give a shout out to. Please use this chance. And after that, we're gonna learn more about something that Sam mentioned, the action cable. And yeah, so after the break, we're going to have Vladimir. So we're going to have the open mic, then Vladimir talking about action cable and any cable and essentially WebSockets and Rails. And then Alan with some hexagonal architecture. I'm looking forward to it. I need to learn what it is. So yeah, see you here in 15.
Hello, I'm Justin Bowen, and I'm building ActiveAgent. ActiveAgent's an open source AI framework for Rails developers to make agentic apps. Working on a new release, hope to have it out tonight. If you're interested, go star the repo. You can check out the pull request and test it early. Would love some feedback, and yeah, thank you. Oh, next. Oh, question. It's an AI framework for Rails. Yes.
Hello, everyone. My name is Hyunsuk, and I'm from South Korea, Seoul. And I'm running my own startup like Jetic AI. I am the co-founder and the CEO of the Jetic AI. And we are like building the AI infrastructure for the mobile domain. So we are enable those kind of AI computation in the like each of your palm and pocket, every smartphone, not only for the latest smartphone, but back in the smartphone like iPhone 13, all those kind of things as well. So we are specializing in utilizing those kind of like mobile hardware. Like actually, I've been working for the Qualcomm. I've been working from the Qualcomm until last year. I started my own startup, and now I'm utilizing not only for the Qualcomm devices, but also for the Apple's one and MediaTek and every single processor in your like smartphone. So like upcoming March, we are gonna open our software to the like everyone to utilize your own smartphone and every other smartphone by our software stack as well. So please be attended and let's keep attention to our company, and thanks for hearing.
Can you please repeat the name of the company and how people can find you?
So my company? Yeah. My company is Jetic AI, and yeah, here's my company's name. I'm the human Jetic, so yeah. Please visit our website. It's jetic.ai, and we build our own software stack, and you can utilize our software SDK to your like AI model, not only for the like object detection or for those kind of like, not for those kind of specific AI model. You can utilize your model, any type of your AI model. Now we are trying to support those kind of AI agenting models as well. So, you know, those kind of like GPT and those kind of that heavy LLM models are not runnable in the mobile devices, but those kind of like 1.5 billion parameter model or those kind of SLLM models around that size are quite runnable. So just let me know. Then I have like running LLM by the DeepSeek like mathematical teacher in my pocket. So let's contact me. Let's talk to me. Yeah, I'll show you. All right. Thank you.
Hello, my name is Federico Ramasho. I'm a software engineer and I built a platform called Pre-Vetted AI. So if you're looking for a job, you should check it out and sign up. If you're looking to hire, what we do is we screen the best 2% of software engineers with different technologies. We've been doing this for 10 years. We built this platform recently. In the last 3, we were able to achieve 100% success rate. Sounds too good to be true, but that's the reality. And we had 3.5-year average tenure. We have people 6-7 years working on the same project, on the same teams. 30% of the people that we present and ended up getting promoted to leadership or different, taking more responsibilities. So yeah, and if you check it out, ping me and let me know if you have any comments or feedback, because that way we can improve it. Okay, thank you.
Hello, everyone. My name is Michael. I built a startup called QuantoFlow. We are an all-in-one AI anti-money laundering platform. So know your client, transaction monitoring, and government regulatory reporting. We just built our MVP yesterday, and we're looking for our first design partner to build out access to the government API, so FinCEN's beneficial ownership information reporting API and other regulatory reporting APIs. So if you know anyone who works in banking, finance, fintech, crypto, who has troubles with KYC and reporting issues, please let me know and come see me afterwards. Thank you.
Okay, I'm not gonna offer you any AI, sorry. Just as a plea to ask you, not only for Californians, but around the US, to support your library in any way you can, because there is a kind of dark times right now. And libraries will be, because there is not to be a Nostradamus to know, the library is going to be target. And they need your support with any way, which is basic as to just go there, read a book, ebooks, do a donation. But the thing is, need to be move. There is need to be activity on the library, so your public library, I mean. The US has a very good library system. Something like I tell you as an immigrant that in my country, there is nothing like this. Well, just a few places, but just use it, just go there, check out a book or whatever, or anything. For example, here in Bay Area, a lot of libraries, public libraries have excess of books. They can sell it to you so you can adopt a book. For example, I bought this book, which originally was for $24, $25, only $2 now, this one. It's not about AI neither. I think it's the complete opposite. But that's it. Thank you.
Hello, hello. So my name is Brandon Weaver, for those who don't know me already. So we were talking with Joel whenever he's up here on stage, like, oh yeah, the XKCD. I should post that to where? Huh. We don't have one of those yet, do we? So now announcing unofficially the San Francisco Ruby Discord or Slack or whatever we're doing. So we're going to take a straw poll real quick. Who wants Discord? Okay, who wants Slack? I think Slack won. Okay, San Francisco Ruby Slack. I will make it sometime later tonight, post it on Blue Sky at BA Weaver or LinkedIn. Brandon Weaver, you can find me over there. I will post a link to that, and I will post the link to the XKCD as the first thing. Thank you, Joel.
Vladimir Dementyev is the head of backend at Evil Martians, the product consulting company focusing on developer tools, startups at early stages that we run together. Vladimir is also the author of a bunch of open source tools, including Action Policy, TestProf, Ruby on Rails, Docker. By the way, the recent Rails on WASM article that was featured by Ruby Weekly, by the way, thanks to Ruby Weekly for that. Just a bunch of stuff, including the alternative implementation of Action Cable, which is called AnyCable, and used by many larger Rails companies.
Okay, sorry for the long introduction. Luckily, I don't have any in my slides, so we're just going to talk about stuff. Remember, I have just 30 minutes. I've been told many times today that I have just 30 minutes. You've been here at the very first SF Ruby meetup a year ago. I spent like an hour and a half for my 30 minutes talk, and we had to leave the place before even getting pizza. Sorry for that, if you've been there. Today, I'm really going to be presenting quickly. Not because I'm going to be fast, just because I don't have enough slides. And no live demo, luckily. Okay, so the talk is called Presences Ain't Perfect. And this is going to be talk about real-time web applications built with Ruby on Rails. That's actually a title of the book on stuff like Action Cable, Hotwire, blah, 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 which is, I'm not sure if it's coming ever, but it's being discussed at least with the publisher, so we'll see. But there is a book which looks very similar which is already available. It's not about real time, it's about Rails and application design and architecture and all that stuff. I have a couple copies and I'm gonna give away them after the talk to whoever are gonna answer some questions or riddles I'm gonna have in my talk a bit later. So let's go talking about something that could probably make it into the book if I write it. Patterns and pitfalls of building real-time applications. Here I would like to road back in time and talk about my RailsConf talk like a few years ago, where I actually covered all the most important, I would say, problems that might occur with the application. With a real-time application, when you start building it without thinking about the difference of working with persistently connected clients, communicating asynchronously compared to our regular request response paradigm, which is the primary paradigm used in web applications. And there was a short overview of the presence problem. And today I want to talk about it in detail. So what is presence? Remember this one. Raise your hand if you remember. Okay, that's cool. Maybe someone of you even remember the ID number, like the short one if you had, probably. Mine was like 9 digits, not cool. Anyway, so what is presence? Presence tracking is the functionality that tells users or your application who's online, who's present in some context on the page, in a chat, whatever. So in ICQ, when someone's online, you see the green flower. When the person is offline or using some settings, probably, they're like always shown offline, you see them as a red flower. As simple as that. Now let's talk about how we would build this feature with Rails, if Rails were when ICQ was born. The quickest thing, like the simplest thing that comes in mind, like building something like that, let's create a channel with action cable, subscribe to updates, and just stream some events, the broadcast events, whenever someone connects to this channel or disconnects from it. So my first question would be, what's the problem with this approach? The very, who knows? Yeah. Yep. Sorry, I can hear you. Yeah, but not well. If you close the browser, the WebSocket connection is closed, and that's okay. The unsubscribed would be called because that's actually being called when the client disconnects. We're going to talk about it in a minute. Any other ideas? Yep.
So the stream events needs to be recently of time.
But we don't need persistence. We don't need to know who was online when. We want to know the current state. But yeah, when we load the list, we would like to know that. But there is another problem. No? Any other ideas? Any suggestions, probably? Well, I think ICQ is not the best example for that because if you come back in time, you think, what could be a problem here? But in the modern world, the biggest problem with this approach is there could be multiple sessions. There could be even multiple tabs in the browser or devices or whatever, and they could disconnect in any order or connect. And even given that you don't have persistence, you do not track anything, the actual UI would reflect invalid state. So no book to anyone yet. We're going to have more questions. So we can fix this, right? Let's do persistence, right? We can track session IDs, whatever it is. There is no such thing in Action Cable, by the way, but we can invent it, but just use some random unique ID for every connection. And we can track sessions in the database and Redis, whatever. It doesn't matter. And whenever there are no sessions for a given user ID, then we notify everyone that user has left. And the same for the join event. Sounds good, much better than the original version, but still there are problems left. And those problems are not like application level related, but the actual I would say, framework, protocol, and the transport layer problems. Let's take a look at how action cable works by the example of the unsubscribed callback when it's being executed. So we have a WebSocket as a client connection. We have our server and some abstract representation of this connection in the Ruby code. And then we have our Rails application, which is being executed from the worker pool. Not a big deal for this example, but good to know that there is some asynchronous task with a limited concurrency happening there. So our happy path is as follows. The client disconnects, the close event is being invoked at the server side, and it goes for the worker pool, Rails executor finds our connection class that calls disconnect callback, and then it calls unsubscribed callback for every channel. That's good. We can keep track of everything. Now, what happens if the closure of the connection wasn't normal in terms of TCP? So there were no closed handshake completed. In this case, this is actually a common scenario with mobile devices when lost connections or Internet of Things stuff when you just unplug some stuff. In this case, web server still thinks that the browser, that the client is connected, but Action Cable has a solution for that. It sends periodical pings that actually used by both ends to identify broken connection. Whenever server fails to write a message over a TCP connection back to a socket, it identifies this as closed and performs all the regular steps. The problem here is that it relies on the TCP settings, and for most applications, they stay default, not suitable for real-time communication, and the default means this could take up to 15 minutes for a server to detect that connection is broken, that it's dead. And it's not the big deal in terms of connection tracking, so I think it's a 15 minutes lag between the online status. For some applications, that could be critical. It's more a problem for load on intermediate servers because they have to maintain the state for half alive or almost dead connections, but that's a different topic. And of course, there is a case of a server crash or forceful termination or short graceful termination timeout when the server have not enough time to execute all the callbacks. So in this case, the chain is broken and there is no disconnect and unsubscribe code at all. So we can leave our application state in an inconsistent state. So let's take a look at how some people and some applications solve this problem in Rails. Just a couple of examples. The first one is a really good article by Stanko exploring how to track online presence with Action Cable. It starts with same things we already talked about today. So we have subscribe and unsubscribe callbacks, and we have some database-backed persistence for the number of connections. All good here. And we also have the important part here is that he couldn't solve it with the stock Action Cable, so he had to patch it, add additional PONG support to ping messages. So whenever we add PONG support, we expect a client to respond to our ping messages, and that eliminates this lag for TCP connections, keep alive mechanism, so we can quicker identify the broken connection. But that requires patching Action Cable, and this patch actually has been proposed, but no PR to Action Cable is accepted except like minor bug fixes. That's a different topic again, maybe someday. Let's take a look at another application. And if we're talking about Rails, we of course should first consider like canonical Rails applications, the applications built by Rails authors, original authors. And we have one kind of a source available, not free, but available. So we can take a look at how they deal with this problem. It's a campfire. I'm going to show the kind of reverse engineering. What do they have? They have some heartbeat channel, which is kind of a ping and pong stuff, and they have a presence channel. And what's interesting in this presence channel is that they have periodical refresh actions being sent by the client. So, and that's an example of an application level heartbeat implementation to make sure that presence is consistent. Well, I'm not going to show you the code. I'm not sure I'm allowed to, so I don't want to have problems with those guys, but I can tell you what's inside. So as before, we have callbacks in this presence channel after subscribe and after unsubscribe. We have this refresh method that is invoked every 50 seconds. That means that could be an actual log of 50 seconds between the connection that someone left Campfire and the system actually detected that there is no user anymore. And there is a connected attribute for membership, which is being updated for every refresh. So we can compare it with the current time and see, oh, if it's more than a minute, then the user is offline. So that's the logic behind Campfire presence tracking. What we see common in these two examples is that everyone is relying on channel callbacks. Well, that's probably why we have them in Action Cable. There is an example of expiration-based presence, like in Campfire, or I know many applications use Redis for that to reduce the load on the database, because you don't want to update a record every now and then. So we can put data in Redis, and Redis sorted sets work great for that. And there is always some application level heartbeat. Either you do that with Pong messages or custom code like refresh in presence channel and Campfire. The problem with this, from my opinion, is that requires too much ceremony to build a robust presence system in your application, given that you have batteries included framework, when actually not every battery is included. A lot of stuff for better experience, you must build it on your own. And that's why I personally been thinking about this problem for quite a long time. And we were trying to find a way how to solve this problem and provide an API for Rails, and not only Rails applications, that would be, well, as simple as possible and provide all the guarantees we are looking for. And that's how we ended up with the presence implementation in Anycable. I'm not talking here about what Anycable is, which probably the slide is missing. So what is Anycable? Anycable is a WebSocket server. It's a real-time server, it's not only WebSocket, that acts as a proxy for your WebSocket or real-time connections in between clients and your backend application. So Rails application in particular. For Rails, it comes with a plug-and-play adapter to work with Action Cable. For other frameworks and ecosystems, it just provides an API over gRPC or HTTP REST to communicate with the backend. Or you can use it as a backend-less, just a real-time server similar to like passes like Pusher, Ably, whatever. So it's a multifunctional tool. But we're talking today in the context of Rails, first of all. Presence in Anycable is a rather new feature. I would say it's not yet released in its final version. We just released a few release candidates in the end of the previous year, but it's already available to everyone in our open source offering, I would say. So that's an example of the application that's using presence features provided by Anycable. So it's like a Slack or Discord, whatever, channels, things. And we have statuses here on the left. In every message, we can see that they appear and disappear whenever a user joins the application or leaves it. And it's all built with Anycable using two different techniques provided by the presence mechanism we offer. Let's take a look at the online indicators first. So for that, we have a dedicated channel, which has very kind of minimalistic implementation. We stream from some, oh, sorry. Okay, let me go back. Wrong button. Just a second. Ooh. Go back. And again, and forward. Okay, we need to wait for animations. Okay, so the only important bit here is that we have a new API method for channels called join presence. When you define a unique identifier within this presence set, and some additional information which could be used by the application. Could be nothing, could be anything. And that's basically it. We don't have an unsubscribe here because the presence set is the record is being removed from the presence set whenever a user disconnects or unsubscribes from the channel. So we don't need to do that manually. It doesn't make any sense. So it's tracked by the server. And the actual UI part is implemented using stimulus controller and stimulus target callbacks. So every UI element that need this tracking information, online tracking information, just marked as data online target, whatever user. And we just toggle the class when we want to highlight, show the online indicator. So it's the same for messages or direct messages placed, whatever. So the implementation is using some API provided by Anycable client here. So like getting presence info and subscribing to events. And that's it. So you don't need to deal with like heartbeats, expirations, whatever. That's handled by the server. Let's take a quick look how it works. Let's compare it to the Actioncable version. So we have three components here: client, an Anycable server, and optional Rails RPC server. And for the online channel, what happens is that Anycable performs an RPC request to Rails, which translated to channel subscribed, that calls presence, and it's registered within the presence agent and propagated to all the clients and everyone who wants to know about the presence events. To keep presence alive, we have an internal heartbeat, which is not visible to clients or servers. It's just for keeping information alive. In addition, you can add PONC messages support, which is another feature of Anycable to deal with connections that could close abnormally. And when the connection is closed, the keep alive timer hits and we remove the presence from the presence set and send the leave message. What's important here is that we're not relying on the actual disconnection event. We rely on the fact that keep alive stopped. So we do not receive the heartbeat. And only after that, we notify everyone that presence has ended. That's important because that could eliminate presence event, kind of a burst when user reload the page or navigates or whatever. You don't want to mark him as offline for this tiny portion of a second when the page is being reloaded or whatever. So you keep some gap to keep the presence alive. And that's what makes this approach different from all the like known to me at least implementations in Rails world. And of course, one more thing here to add is that you don't need to use RPCs or whatever stuff and control everything at your server side to work with presence. You can do this completely from the client side and using like join commands or leave commands and so on. And that's becomes especially useful if we want to build something like without writing JavaScript or even writing server-side real-time code. And I'm talking about Hotwire. So when you work with Hotwire, you don't write channels, you don't write subscriptions in JavaScript, you just write HTML. And we want presence to work with HTML too, because why not? Like people love Hotwire. So we want to give them an opportunity to benefit from these features when using Anycable. And we already have this in our demo, the one that I showed before. We have a channel presence list, which is an indicator with a number of people currently watching this channel and the list of users. And it's built only using HTML, and that's almost all the code except CSS classes and other stuff required for that. So how does it work? We have a custom HTML element. It's similar to Turbo, Stream, Source, whatever element that provided by Hotwire, but it has some additional attributes to control the presence. So it's like presence ID, it's a unique user identifier, and some options like here we have ignore self. We don't want the current user to be present on the list. We want to see only other users. So that's why we add this option. Then we have some hacks to provide another useful information when dealing with presence, like the number of total users active on the channel. And we have a special selector for that. So you don't need to, again, do anything on your side. We just update the value. And finally, how do we update the list of users? And for that, we use turbo streams. So every presence record attached to a user for this particular presence set is actually an action, a turbo stream action. It could be multiple actions, by the way. We can add a flash message, for example, to the list of actions, telling that, oh, user joined, oh, user left. And everything is controlled by turbo. And under the hood, the presence element just takes care of executing these messages whenever the presence changed. Right now, we only support remove action as a left action. We just use the presence ID as identifier, but we plan to extend the API to provide different templates for join and leave events, so you can customize them both. And that would give you, well, an ability to build pretty much, well, not say anything big, but most use cases could be covered with just Hotwire and any cable presence without dealing with JavaScript, state synchronization, whatever. So that's something I just released, I would say today, maybe yesterday. Well, it was broken yesterday. Now it's fixed. So anyone could try. So any cable presence takes care of all the low-level stuff that otherwise you must write yourself when using pure action cable, like heartbeats, expirations, and stuff. And you just have some APIs to work with it. And that's just an example of APIs used to add and join and remove records from the presence set. And everything lives in the server, at any cable server, not in your application, which might be not what you're looking for. For example, you want to store the online state in the database, right? Sometimes it could be useful for some operations. And for that, we right now working on the kind of a second batch of features for presence is for pull and push kind of versions of getting information from the server to your application. So it's a REST API or webhooks you can use to integrate presence information into your business logic. And that opens other possibilities beyond chats and all this messaging things, because like that's not the most interesting thing we built, right? For example, what we have on the list, on the roadmap, is our UI kit, and it already comes with some presence-related features like locked, like, I forgot the name, it's like a collaboration, it's like not real-time collaboration, but like a multiplayer collaboration step-by-step. When, for example, you work on the same form, but only one person can edit a single field at a time. That actually another presence example, because locking a particular input is actually presenting on this input. It could be implemented with this API, but that would require integration with your backend, because you want to know who was responsible for which part of the form on submit and similar stuff. That's coming a bit later, I think, but the underlying infrastructure is already around the corner. And I think that's it. We don't even wasted half an hour, and I still have 2 books. So the rules has changed. The rule has changed. We're gonna give away books for good questions, I think, right?
Yep.
Let's start with questions.
Yeah. Is it open source?
Oh, yes. So yeah, that could sound like any cable is like some product, AI based, so we can get some money. No, no AI, no money. Any cable is open source project. We have a pro version that's kind of it's commercial version, like right, which is only needed if you have a certain scale. So it's different from open source version. It has some features for cluster-based setups, but most of the stuff is open sourced. So you're welcome to choose it. We only have a managed version called AnyCable Plus, which is free and comes with pro version, by the way, with all the features. I don't have links here. Yeah, we have a lot of stuff here.
Yep.
But let's continue with the questions, probably.
So I've got 2 questions. One is, what is the primary problem that you were trying to solve that wasn't already being solved? And the second is this like purely middleware that intercepts all requests, or is there a way to kind of only allow this server to, like, for efficiency purposes, be served up on certain routes?
First, like regarding the first question, do you mean like the present stuff or any cable in general?
Yeah, both.
Both. Okay. Quick overview. So any cable was born as an attempt to make action cable not suck at any reasonable load. So like action cable is like just has poor performance unless you drop money into servers like Basecamp does. Good for them, maybe, or for US economy. Anyway, so originally it was mostly about performance because it scales. The server is written in Go and it's highly optimized for WebSockets, and it can handle much many connections, like wasting the same amount of memory. First of all, like it's for resource usage and for latency. If you care about it, it's also much better. And presence just well, that's a feature that everyone wants among our clients, both open source and commercial, because that's an essential part of the real-time functionality of many applications, most applications. So you can build your own, but as I tried to at least demonstrate, that's actually harder than it seems. And we don't want people to, we want to lower the bar of building real-time applications by providing a working solution out of the box, so you don't need to worry about all that stuff. And could you please repeat in short?
Yeah, the second question was just about like it serving as a middleware to the server.
I would say it's more like a proxy, more like a WebSockets reverse proxy, I would say, because that's one of the mode you can use it. So it stands between WebSocket clients and your application, Rails or whatever, and it translates WebSocket messages into RPC calls. So you don't have to deal with handling connections, broadcasting, and all that stuff. That's, again, the original design of any cable. Now could be used as a standalone real-time server, like Socket.io, but better, like Pusher, but better and free. So something like that with all the features.
Hi, so great talk. I wanted to ask about server-side events. So WebSockets are like bi-directional, right? But there are many use cases out there that don't really require a bi-directional interface and more. It's so just unidirectional, aka just server-side events. So I just wanted to ask, does any cable support server-side events? Does it have the same performance as like a raw SSE request?
Short answer, yes. Server-side events are supported as well. And they also use the same action cable protocol. So we can use server-side events to connect to your channels. You only, as you mentioned, so it's unidirectional, so you cannot perform actions, but you can subscribe and get updates. And when you subscribe, you can stream joint presences similarly to, like, for example, in this case, online channel, we only had the subscribe logic. It could be used with server-side events without any changes. So we can just curl to the server, any cable server, and join the presence set and even get updates on presence from other users. So yeah, server-side events are fully supported as well as much as it's possible for server-side events. And we also have support for long polling, if you're interested, only in pro versions, sorry, because if you still need like HTTP fallbacks for real time, you're probably dealing with some old shit for banks and stuff, and you can pay money. So
Thanks. Thanks for the presentation. I have a question about PubSub providers. Does it support Postgres, Redis? What do you recommend?
Yeah, good question. So we support, out of the box, we support, like when you have a single instance of any cable, you don't need any provider, it's just implemented internally and like in memory structures. And you can use HTTP to broadcast messages. So send, publish messages. And of course, we support Redis. This actually was the original one because, again, because of Action Cable, we heavily inspired by limitations and use cases of Action Cable. And we also support NATs. And even more, we have a built-in embedded NATs support. So you don't need to run NATs yourself. You just enable it within the any cable server, run multiple servers, and then form a NATs cluster with each other, and everything works almost like only by the matter of few configuration settings. Speaking of databases, so there were some even requests for support in SQLite, which I don't think it's a big deal for like PubSub. Because like we have a memory struct that works just faster, but now when we have presence and some persistent information that kind of could be critical and should survive deployments, restarts, we thinking of adding some database-backed presence engine implementations. So it's not a PubSub. Like, okay, our documentation has some scary charts of how any cable works. Yeah, because any cable is designed in a way that every component is separated. So it's like component-based architecture. So PubSub is a component, presence is a component, there are a few others, and they could all use different backends, infrastructure backends, from memory to Redis to NATs to databases in theory. So yeah.
Postgres?
Yeah, we can add Postgres. I don't just think it's probably the best idea, especially for presence and streams history, because that would require frequent updates, and that would work not so good with Postgres and VCC after vacuum and stuff. I think that like using a separate database in some serverless Postgres, yeah, for sure that's going to work. But just a matter of a feature request, actually. So it's, yeah.
Yeah.
If you really needed it, just ask.
Submit a feature request.
That's an open source project.
Well, who gets the book?
So the person who was asking first two questions, so that's the first copy. And I think the last question also deserves something. Sorry, I just brought two books, so it's probably not fair. We need it free. Anyway, thank you very much. Feel free to ask any questions, and let's leave some time for the final speaker.
Thank you. By the way, there is a connection between Cisco Meraki that Alan works at, and GitHub. And you know what? What connection?
Know what that connection is?
Yeah.
No.
No. Okay. Do you guys know?
We are
do you know?
two of the largest.
Right. It's what the guest Wi-Fi was right here.
We're also two of the largest Rails apps on the planet. So there's that. All right. So my name's Alan. I work for Cisco Meraki, and I'm not going to talk about them much tonight, a little bit at the end. But Irina asked me to come and talk about hexagonal architecture tonight. So I thought I'd start by asking you guys, who's heard of hexagonal architecture? A few of you. Awesome. How many of you have actually used it? Fewer of you. How many of you have used it with Rails? Just a couple of you. Okay. All right. I'll try to customize this to meet your needs as an audience. Can't find my mouse again. There it is. All right. So what is it? What is hexagonal architecture? It kind of sounds imposing, like it might involve 6 or something, might be daunting. But in reality, it's quite simple. It's an architectural pattern that only requires you to know 2 things. You need to know about ports, and you need to know about adapters. You should probably also know who came up with the pattern. It's a man named Alistair Coburn. And yeah, that's his picture. That's his actually LinkedIn profile picture. So what are ports and adapters? Well, a port is simply an interface your application exposes to or expects from the outside world. It's how the outside world interacts with your application and vice versa. In a diagram, applications are drawn as hexagons, thus the name, and ports are drawn as either circles or semicircles. The circle represents your API. This is your application programming interface. These are the public methods that your app exposes to the rest of the world, so that other software can drive, including tests, can drive your application. You can think of these as like just inbound messages to your app. Semicircles represent a service provider interface, or SPI. These are the methods that your application expects to use to drive another service, like a database or a notification service. You can think of these as the outbound messages that your application is sending out into the world. So most applications, many applications, the software that's driving your application just hard codes references to your API. And likewise, you might often hard code references to service provider APIs, say SendGrid or some other API that you're using. As a result, anytime one of those APIs changes, either yours changes or one that you're using changes, you end up having to change your application code because you've tied yourself to it. And that is where adapters come in. Oops, Google Slides, don't ever press spacebar. So an adapter translates one object's service provider interface. So the object is, say, a messaging service. Its application programming interface is translated into the interface that you expect that you're actually going to call. So for example, say you've got SendGrid in your application today, you're moving to MailChimp or something like that. They don't have the same API, but you don't want to change your application code. So you introduce an adapter between yourself and the service provider that understands how to provide the service to your application, and then you can swap out which adapter you're using, whether it's the SendGrid or the MailChimp adapter. You can think of it like this. There you go. There we go. So it's kind of like a jigsaw puzzle piece, that adapter. It connects 2 differently shaped pieces. And here the 2 adapters are shown in red. The yellow application is the application that's driving our code. And it's doing so through that inbound adapter. The green application is a service that we are using from our application, and we're calling it through the outbound adapter. For simplicity though, diagrams don't ever look like this. That's too complicated. It took me an hour to draw that. They look more like this, where the adapters themselves are implied, and all the APIs are drawn as circles and all the SPIs are drawn as semicircles. And so that's it. That's hexagonal architecture. Not quite, not quite. I don't have the same issue that Vladimir has. Nothing else matters here. It doesn't matter what happens on the inside of your application. It doesn't matter what happens on the outside, as long as you have exposed an API and expect an SPI, and as long as you have adapters in between you and those other things. That's the pattern. But why would you use it? Well, that way you're isolating your application code from the runtime environment, allowing you to swap things in and out as needed. For example, you may want to mock a service when testing your application code, or you may want to switch your notification vendor like I already described. Or you might actually want to upgrade Rails. You might want to isolate yourself from Rails so that it's easier to upgrade when it comes time. By isolating your applications from their runtime environment with the adapters, you'll never have to change your most valuable, most unique code just to swap out a service provider. What you get is applications that are easier to test, easier to maintain, and easier to extend. So let's take a look at a simple example. Wouldn't think you'd get out of a Ruby meetup without seeing some Ruby code, would you? All right. This is a simple coffee machine. Now, when something calls the coffee machine's dispense API, the following process is invoked. It dispenses a cup, heats some water, grinds some beans, dispenses the hot water, and then disposes the grounds. Now, under the hood, each of those methods are actually implemented by private methods that manipulate the mechanical hardware to produce a cup of coffee. Now, if we owned both the hardware and the software in this scenario, we'd likely end up with code that looks kind of like this. One class that does all the work. But would that code still work for our new coffee machine? Well, the recipe hasn't changed, so in theory, the dispense method should just still work. But the underlying hardware is all new, so none of those private methods work anymore. Now, at this point, most folks would likely just rewrite the private methods and call it good. And that's the problem with simple examples like this. When you have much more complex code, that's not likely desirable. So please suspend your disbelief here while I take a few minutes to refactor this using the hexagonal architecture. And then we'll take a look at it at the end and see what how it turns out. So the goal here is to get to a point where that coffee machine class will never have to change again. Because really, what's going to change the recipe for coffee? All right, so the first step is to extract drivers for the cup dispenser, the boiler, the grinder out of the coffee machine. Now, this change does require us to change the existing coffee machine class to call the new drivers. It's pretty simple. The next thing we'll want to do is inject one of those drivers, or each of those three drivers rather, into the coffee machine, which allows us to then swap them out with the new drivers when we have the new hardware. Or we could swap them out for test dummies, and so forth. This allows us to call the coffee machine class like this, where we're just newing it up, passing in the various drivers, and dispensing the beverage. So in theory, now we can just swap out the drivers like this. And if we controlled the whole thing, again, we might stop there. But let's assume we don't. Let's assume that in a cost-cutting move, our company decided to use third-party hardware components. So the APIs for those various components aren't the same as the SPIs that our coffee machine currently expects to use. So for example, you can't see it. We're calling cup dispenser.dispense cup, but the Couple-matic might actually have a different interface than that. So here's what the new hardware drivers look like. Note that I have not yet changed the underlying coffee machine class here. But sure enough, the couple-matic has a drop method, not a dispense cup method. So here's what the new code in the coffee machine class looks like. Did I skip something? Nope. Here's what the new code looks like. Note that there are adapters now for each piece of hardware. And below that is what one of the adapters might look like. It's simply just translating the call from dispense cup to drop. So it's not changing our SPI, what we expect of the outside world. We're still calling dispense cup, but inside the adapter, we're adapting that into the actual API for the couple-matic. And that's it. That's the entire architecture. Now that we've implemented it, we'll never need to modify the application code again. That's the coffee machine class in order to accommodate new hardware. We've externalized that hardware driver and put adapters between us and them, allowing us to swap them out as we want. So that is how to refactor a tiny little application to use hexagonal architecture. But again, why would you? In fact, didn't DHH balk at hexagonal architecture a decade ago? In fact, he called it test-induced design damage, which is funny because his application back in 2019, which was 5 years after he said that, was only 35,000 lines of code. There are many, many much larger applications than that in the world. At Meraki, our main Ruby app is over 2 million lines of code. Shopify, GitHub, Gusto, Zendesk, they all have very, very large monoliths. And so, with all due respect, David didn't really know what he was talking about. And in fact, he acknowledged as much when he joined the board of Shopify. He said, I wanted to wrestle with problems at a scale that none of my own work had ever touched. So hopefully he'll see the light. So what does it actually look like in a Rails app? I showed you just some simple Ruby code here. What does it look like in Rails? In Rails, we might have a controller like this that delegates to a model to do the work of brewing the coffee. Now, this model would include the recipe and all the private methods that we refactored in the previous example. So the first step in refactoring this code to hexagonal architecture is to extract that code out of the model into a coffee machine class, just like the one we started with earlier, and then follow the previous refactorings. So you should end up with something that looks kind of like this, where the coffee controller delegates to the coffee machine class, injecting the cup dispenser, boiler, and grinder adapters. It's pretty simple. The key to using hexagonal architecture with Rails is to write your application in PO-rows and leverage Rails as the adapters between you and the outside world. Basically, Rails, you're just treating Rails as I/O. That's all it is. It's handling web input and database output. So one trick though is that if you plan to upgrade Rails over time, you might not want to actually take direct references to Rails API. So you can use this pattern to put adapters, like say a repository pattern, between you and Active Record, so that when Active Record's API changes, you can upgrade just by swapping out the adapter. Ultimately, like I said, the idea here is to let Rails recede into the background so that you can focus on the most important bits of your application, those bits that make your application uniquely yours and uniquely valuable, your business logic. In fact, if you begin development by test driving your application code as PO-rows with mocked or stubbed repositories for data access, you can put off the decision about which web framework to use until you have more information about your application. Who knows? Sinatra, Hanami, Rhoda, any of them might be a better choice than Rails in your particular situation. But you won't know that if you start with Rails new. So this is what it means to isolate yourself from the runtime environment. And the benefits are code that's easier to test, easier to maintain, and easier to extend. And that's it. Do we have time for questions?
Hey, greetings. I was talking to Charles Nutter, who's the JRuby guy, recently, and he said, I was asking what projects they need help with, and he said the Postgres driver is always a mess because Rails had a MySQL driver, and the Postgres driver was a kind of a wrapper kind of transformation thing, and it's just full of a mess. And I feel like the same thing happened when you have an API and you kind of cache some data in a structure, and now you hook up to another API as an option, but you have to sort of either just force it into the old format from the first API. So how do you kind of evaluate the amount of work to transform the internals when you're trying to adapt to the external things and avoid that problem?
So I've not, I don't think I've actually run into that. I know what you're talking about. I've talked to Aaron Patterson about it. He's, he admitted that nobody on the core team has any Postgres experience. They're all MySQL guys and women. What you're talking about specifically is transforming, say, like a data structure that comes out of one API into something that's expected by the other object. And the question specifically is like, when does it?
Yeah, so if you want to embrace this, do you try to sort of look at the API and say, how do I take the data that I'm caching and sort of figure out what am I going to do with it with an eye to future proofing, or is that just building towards something that doesn't exist yet? As soon as you get the second API, is that the time you say, how do I approach this so that I'm now avoiding this trap of, you know.
Yeah, so if you have, I'm going to repeat the question, make sure I got it. If you have one API and you've added an adapter between this and your other API and the service provider that you're using, like at what point do you then start thinking about the mappings between additional APIs? Is that correct?
Yeah.
Okay. I don't start thinking about it until I have that second API to deal with. And it might have an impact in terms of, it's really just a classic, gang of four adapter pattern. You're not trying to predict what the next thing is going to be. You're just going to write an adapter that takes that data structure and puts it into the data structure that you're expecting. So hope that answered your question.
Sorry, that was not.
So is hexagonal architecture really just the adapter pattern at a larger scale?
As I was putting together this talk, I kept having that thought. It's the adapter pattern. What's interesting about it, though, is the use of the word port in terms of defining your interfaces as ports to the outside world. So literally, and listening to Alistair talk about it, it's like a serial cable. Like there's a port that you plug into, right? The web is plugging into your port. So.
Hi, thanks for your talk.
Thanks.
Great job, by the way. I think my question is similar to the first question, but I'd like to provide an example of where I think that question came from, tie that back to the examples in your talk. So I think a lot of us have had experience with adapters, specifically when it comes to calling third-party APIs, right? Like Stripe or what was the column, right? From Sam's talk.
Mm-hmm.
And in those cases, you might have two APIs that do similar things. In case of column and Stripe, I assume you're charging credit cards and recording those transactions. But because those APIs are different, they require different inputs and they provide different outputs. And occasionally, in many cases, I have found that those are different enough that they don't make sense to treat as the same thing and therefore don't lend themselves super well to being adapted. So as an example from your talk, let's say that our coffee machine, we first start out with the regular cup dispenser, and that cup dispenser just dispenses one type of cup for one type of liquid. But the Cup-O-Matic now dispenses cups that work with two different types of liquid, and you need to specify what type of cup it should dispense.
Or just different size cups.
Or different size cups is a great example. Yeah. So that information has to come from the application. It can't come from anywhere else. And so the question is, if I'm going to stick that swapping that cup dispenser out for the Cup-O-Matic, I now have to know that it receives different arguments and needs different data in order to dispense the same kind of cup that was dispensed before. And knowing that information and knowing to pass that in sort of defeats the whole point of the adapter in the first place. So I'm curious, like how that problem, how you think about that problem and how you can solve for it.
So in that particular case, let's take sizes, for example. That is a new feature of your application. It should not be jammed into the old feature of the application, which served a single size of a cup. So I see that as a new function within the application and a different kind of an adapter for that type of hardware. Now, it's interesting. We can think of those two types of hardware as synonyms or like stand-ins for each other, but they're not. One of them has a feature, the other one doesn't. And so therefore that adapter would never, ever be able to, the interface of that adapter would never be able to like support the new feature because your application doesn't currently support multiple sizes of cups. Maybe you could jam it in and just always use a medium, but if you're actually going to support the feature of multiple sizes or different kinds of liquids or whatever it is, that's a new feature of your application. You build out the new feature and you build out the adapter for that piece of hardware that supports it. The fact that they're both called cup dispensers doesn't mean that they are synonymous devices.
Okay, so a follow-up then would be, sorry, I lost my train of thought. 1 second. I guess the follow-up question would be, does that mean that every thing that you're adapting, so in other words, two different backends, in this case, the cup dispenser and the Cup-O-Matic, they have to support the exact same set of features and call them the same things in order for that adapter pattern to make sense to use in that scenario. Is that true?
No. So if my application, the way it's written today, doesn't need that feature of that piece of hardware, there's no reason for me to build that feature into my app. Then I can reuse the interface that I've already got and adapt it to the new piece of hardware. But I'd be sacrificing that feature of that hardware. I think.
Yeah, I don't know if this is helpful, but what if we think about Active Record having adapters for Postgres, MySQL, but also ClickHouse?
I'm not familiar with ClickHouse.
I mean,
ClickHouse is a time series database.
Columnar, yeah. Column store. But maybe you can ask this question better than me.
I think this goes back to your point about Postgres and MySQL. They are different tools. And Active Record is using adapters to make them, to force them into the same shape so that we don't have to think about which one we're using. It's the same principle. Same principle.
The concept of how Active Record thing work is based on what MySQL did. And by the time they finally figure out how to read Postgres, maybe everyone's used SQLite only and all irrelevant, but you build a bunch of things based on the world, and then the world changes. So,
what the comment was that the Rails core team started with MySQL, and by the time they figured out how to get that to work and they had an adapter for it and they went to apply it to Postgres, the concepts weren't the same. And also, here we are talking about SQLite, and maybe that'll just all be irrelevant So.
Yeah, I was going to ask you about something similar to what Cameron was suggesting, because it's once you move the abstraction of the class into separate object into the adapter, then the next logical thing might be to move the abstraction of the creation of that object into a separate object. And then we get into the infamous factory pattern, right? Like where you extract all the instances where you create those type of object and you put it in a factory, and then you just configure that object, right? So I was wondering, like, what do you think about like going in that direction? Are we going more into the Gang of Four patterns, or is this going to be more configuration oriented?
That's a really good question. So I'm not afraid of using a factory. I like using factories. I love the factory pattern. And I do see that in a situation like this where you might have at boot, you might say, well, this particular device has the couple-matic and the other one does not. And so you could use a configuration file or something that says what hardware is on this machine. The factory gets loaded, you pass that to the factory, it instantiates the right adapter, and off you go. So yeah, I am a huge fan of many of the Gang of Four patterns, and I don't see a problem with using that.
Yeah, folks, my job is also to make sure we're not kicked out of the venue by force. So super inspiring, thoughtful talk, as always, Alan. Thank you. Everyone, so here at the venue, the doors close at 8:50. And somebody wants, we can actually kind of go grab a drink at Victory Hall. It's pretty close by. It's open till 10. Yeah, so we can do that. So we have about 10 minutes here. Let's kind of take this time. And thank you so much for coming today. And I hope to see you again at the next Test of Ruby. And we now have a Slack, folks. Brandon really did create a Slack, and you all will get an invitation. Please don't miss the email from Luma. I'll invite you all. Yeah. Thank you.